So one of the things that we try and do here at CDME is show the art of the possible with additive manufacturing. In the additive manufacturing lab, we're focused on bringing to life some really exciting technologies for 3D printing metals, polymers, ceramics, biomaterials, and all kinds of leading edge technologies. One of the things that we're focused on here at CDME is building a local additive manufacturing ecosystem. That includes our faculty, staff, collaborators on campus, and also the students, but it also goes beyond that with local companies, both startups and large companies that we partner with. I was meeting with a student, Josh Leidick, who works in the lab, and we were talking about a project where we can demonstrate our polymer prototyping capability. And this was right around the time that the NASA Mars 2020 mission was going on. The Perseverance rover landed on Mars. We got really excited, and so we decided we were going to build a Mars Perseverance rover model showing the capabilities of our Stratasys F370 machine.
As an industrial design student, it's such an awesome experience to be able to take something like the Mars rover and be able to have the capability to 3D print it.
We were able to use models from FISNA, which is a local startup company here in Columbus, in order to execute the project. And so that really goes with our vision of building the local ecosystem. One of the things that we try and do here at CDME is show the art of the possible with additive manufacturing. And it's a continuum of different processes. So even if there's a part that we know we want to print in metal or ceramics or biomaterials, usually we'll prototype that part first in polymers. So one of the things that we wanted to show was the capability here, the dimensional resolution, the fact that you can print multiple parts and assemble them into a more complex structure, in this case the Mars rover.
My role consisted of a few different things, the first being attaining digital files of the print. So this included categorizing parts associated with function to the Mars rover. So basically reverse engineering so that when we go to print we have all the right components and number of each. The second would be to physically print the rover utilizing the Stratasys F370 printer. I was using polymer ABS material along with QSR support material and printing various different versions, ensuring that we have all the right components. And then moving on to the assembly portion. So this was pretty the fun part of it, watching the components be put together and seeing the full rover take shape. Seeing these different concepts come to life really inspires me to be able to think that I can take the lead and execute something like printing a Mars rover. Just instills this wow factor in my creativity and just continues to advocate that taking an idea digitally, combining it, assembling it in a digital space, and then take that and not only be able to print it but also have a physical model of it that can be interactive, that can display the capabilities of industrial 3D printing on a small scale, and then eventually take that to an even larger scale, potentially even life size. This project shows if you can make a digital model using 3D printing, we can make it come to life.